Today we're going to be talking about interactivity. So I think today might kind of click more things into place about like what Touch Designer is good at. I can't remember if this was different last time we met, but my plan is today we're going to talk about interactivity, and next week we'll talk about what's called user experience design, which is like how to design an experience. And user experience design is like it has a particular emphasis on like usability. So like thinking about the person that's going to use the thing. And then after that, I want to talk about like the outputs. So today's inputs, all the different ways that you can get data into the system. Then that'll be all the different outputs you could have, types of screens, control, the sky's the limit. And then we might talk about Python a little bit then, but at the very least, I wanted to talk about it on the last week of having more of like an introduction to Python. So that's like the tentative plan. And today we're talking about inputs. And so I wanted to bring this back up again. So this is hopefully making more sense than it did the very first day. And we've kind of been talking a lot about the back end so far, mainly technique, I would say. Like a feedback loop is an example of like a technique. And we're really only using Touch Designer as a technology. So we're kind of coming to like, okay, I can make some cool like visual things happen. And I could probably at least display them on a screen. And today we're starting to get into this side of like, not necessarily how else to display it besides the screen, but really the person that's going to be viewing it, how can they interact with it? And so that's what we're going to start getting into today. And I really have been enjoying teaching this class, almost specifically, I think, for this lecture, because probably like a year ago, I had this idea that I wish I could have like a system that just told me like every type of interaction you could have, and ideally every type of like output you could have, so that if I were gonna like make a new piece, I might just be able to like pick and choose or like swap them around. Yeah, like give me a random input and a random output and then figure it out. But the problem with that was that when you try to isolate every possible way to get stuff in, it very quickly becomes very tedious. And so it wasn't until I was sort of forced to sit down and do this lecture did I get what I think is like a usable framework. But I guess to caveat it, it's not the type of framework where I could have a wheel. So it's a little bit more abstract than that. So hopefully it'll make sense. But I think probably the most powerful part of it is that I had this sort of realization, and I guess I'll challenge you guys to find out if there's something else, that every type of like point of user interaction boils down to either a button or a slider. Either you're going to have something that is going from off to on, or just between two states, or you want a more like continuous change. And no matter how you get the data in, whether it's a gyroscope or motion tracking, in the end, these all get connected to a slider. And so I think if we can remember this, that like in the big wide world of like user interaction, when you're trying to figure out like how do I want this person to interact with my piece, and what do I want the parameter to be attached to, I think it's useful to remember like, is this a sort of on and off binary thing, or is this a more continuous change that I want to happen? And it's either a button or a slider. Now, I would say text is sort of the wild card. And this is a Mad Lib, And I included this because it made me realize that even traditional text input is different enough that it can't be classified as button or slider, except for the fact that you would be typing in the text with buttons. But I mean, think of this sort of input like you might want specific word inputs to do something with them. It could obviously be way more advanced than a Mad Lib. But now we have AI in computer language. This is called natural language processing. So now computers can kind of understand language. That makes language an even more powerful like input in its own category, which we won't be talking about that as much. But I just wanted to point out that in general, we're looking at buttons and sliders, but modern day, this is an important, like, its own category of input that you could use. So one way to think about input is that you're building a system and you want this system to like take in information from the outside world and do something with it. And using this analogy is why people think like the brain is a computer. So there's gonna be like heavy scare quotes around all these that like aren't visible, but like computer vision is an analogy to our vision. But that aside, it does work very similarly. So let's start with these of just like, you basically, at a fundamental level, you want to give your computer the ability to sense the outside world. And a great starting point is the senses that we have. So vision is a very common one. And I kind of forget what this video is. Let me see. Everyone can see this. This is the kind of thing we're going to try and do later today. He's using computer vision to track where his hands are on the screen and then mapping those to sliders in Touch Designer. So now his computer can see his hands and he's telling it, when my hand's here, move these numbers. And you can start to see just in general how far you can take that. He's using his hands, but there are skeleton trackers that could use your whole body. There's more things you could track than just skeleton. It could be just real world position, or you could do silly ones like try to guess the gender of the person or the color of their skin, color of their eyes. You could do eye tracking. Just anything that you could see on a camera. Can you try and like get your computer to understand what that is? The other one is listening. Nick mentioned earlier about a microphone that when you sing into it, it will output MIDI notes. So this is another YouTube short about a brief history of like the math behind that. Basically, every type of audio application you've ever heard of is doing this on a fundamental level.
The mathematician Joseph Fourier showed that any wave can be broken down into an infinite sum of sine waves using a technique now called the Fourier transform. The Fourier transform is like a recipe generator. You input a complicated wave and you get back its ingredients, the amplitude and frequency of each component sine wave. Fourier analysis is an essential part of modern technology. Its applications range from JPEG compression and image recognition to quantum physics and MRIs. Fourier theory has two components: basic building blocks and labels. Imagine a child's toy castle. This castle can be disassembled into individual building blocks, and these building blocks can then be sorted by color into bins and labeled. Similarly, the Fourier transform disassembles a complex wave into individual sine waves. These are like the building blocks. Each sine wave can be labeled with its frequency, or how quickly it oscillates per second. The labels on the bins are more than just a way to organize things. They can be used to rebuild the original complex wave. The labels on the bins are more than just a way to organize things. They can be used to rebuild the original complex wave. They can be used to rebuild the original complex wave. and as an efficient shorthand for communicating information. For example, when you send a voice message, your phone doesn't transmit an entire complex sound wave. Instead, it breaks it down and sends just the labels, or frequencies of the component sine waves. The receiver's phone then reverses this process, converting the labels back into the contents of the bins to reconstruct the message's original sound wave.
So my favorite example of that is autotune. It's like, how does it know what note you're trying to sing? It does this math to it, breaks it apart, and finds out the fundamental note, and then rounds it to the nearest tone. And the same thing with the mic he was just talking about. It basically does autotune, but then sends out the MIDI note instead of the audio note. And so do you need to know how the formula behind it? Of course not. But in every program that is like, it feels like you're coding Touch Designer included, there's like a module called an FFT, if you ever hear this. FFT stands for Fast Fourier Transform. And so in Touch Designer, a lot of the techniques around like audio reactivity are basically plugging it into the FFT and then getting like a frequency spectrum. And then you can respond to like individual frequencies. And the best part is you don't have to know how to do the math behind it. But this is how we give our computers the ability to listen. We have computer vision and computer listening. These are two of the senses you could give your computer. Now we're kind of leaving human senses. So tactile controls are a big one. I used an Xbox controller here, partially just to, a theme that I'll continue in a second is recognizing that we're making like art installations, but the idea of an interactive piece of technology is like everything in the world, especially video games. So this is a series of buttons and sliders. That's all it is. And so if you wanted to build your own tactile controller for your installation, it would follow the same logic. For one, I believe you could actually just straight up use an Xbox controller. I think there's a way to, like a compatibility with that. But we'll talk about Arduinos in a second, where there are all kinds of buttons and sliders and knobs that you could attach to your custom controller and just plug that into your installation. So definitely remember tactile controllers. And also, you can also separate it from the idea of like this complex custom controller, and it might just be a button. You might just want them to be able to press a button or move a knob. Think like arcade video game. It's the same idea. Biometrics are, for me, where things start to get interesting and start to be like more critical of technology. Hein Kong is the new media professor at Vanderbilt, and her specialty is in EEG machines, so reading brainwaves. And this is a very common, I wouldn't say very common, but it's one of the, if you're going to do biometrics, it's one of the like most popular ones because it seems so cool, right? You can make things move with your mind is the idea. So I wanted to show this installation she did involving EEG, and I want you to think, is this connected to a button or a slider or something else? If it doesn't explain how it works, I'll explain it. So what do we think? Button or slider? The button, right? All it is when you close your eyes, it turns on. And to me, the feeling that I imagine having in this installation is that the cool stuff can only happen when your eyes are closed. And imagine being in a room full of people that can see what's happening, but you're not allowed to because it keeps turning off whenever you open your eyes. That's a very cool concept. And I think the usefulness of this framework I'm trying to get across is it can boil down something like this that seems like it would be so complex into realizing all she did was create an on-off switch. And she just found out what data makes that interesting. I can use my brain waves to turn stuff on and off. And I'm not 100% sure, but towards the end, yeah, it said rhythm created by brain waves. So I'm guessing she might be using the other waves as like sliders to affect the motion, but I'm not sure. Because you just as easily could have had it be random motion. But yeah, that's like the idea of biometrics. So from there, you could break it down into any type of sensor you could get your hands on. So this is detecting brain waves. You could detect heartbeats, detect electrical pulses in your muscles. I forget what that one's called. Yeah, basically anything that you can create an electrical signal out of, you can get it into the computer. And so back to the cybernetics idea, giving a computer senses that humans don't have. It's kind of interesting to think about what that would be like if the computer were conscious. Like we have a very intimate relationship with our five senses. But what would it be like to have like GPS as a sense, or EEG as a sense, or sensing the electromagnetic waves around us, Wi-Fi, radio, all of this? You could give your computer these senses and try to visualize them or sonify them, or attach them to a slider or a button. So I think it's interesting to start thinking about what information is just available and how can you get access to it. So another type is chemical sensor. And when I get to the Arduinos, we'll look at specific ones. But I use this again to reinforce the idea that this isn't just installations, this is how the world works. Like this is a smoke detector, or I think specifically like what do you call it? CO? Carbon monoxide detector. There's some sensor that is designed to detect specifically carbon monoxide, and then there's a back end that does something with it. In this case, it'll create a sound and lights. So essentially, it's attached to a button. When a certain chemical reaches a certain level, turn on this button and make these things happen. So the same thing could be applied to an installation. Maybe you don't want to use carbon monoxide, and I don't know if this exists, but I started thinking of chemical sensors when I was thinking about giving a computer smell. That's how our smellers work, is it's some kind of chemical detection. So I imagine if it doesn't exist, it can be made chemical detectors for specific scents that might exist in the air. So yes, so you can detect chemicals in the air, networked interactions. This looks unnecessarily complicated. I brought up this illustration because it's a wireless router, and the point is that computers connected wirelessly can send data to each other. And this is a huge one because sort of in the real world, this is how almost all of our applications work, is cloud computing. So the calculation doesn't happen on your computer, it happens on someone else's computer. And your computer is just sending it a request. So that's like a networked interaction, but also the idea of, I guess I'll explain it later, but like OSC is like, let's go to like an art context. If we have two computers in the installation, I can send your computer, specific messages to make things happen. And also, when we get to Arduinos in a second, this is sort of the core of it is, whether I have a chemical sensor or a tactile controller or anything, it'll probably be connected to like a little Arduino thing. And that will be connected to my big computer over local internet. So yeah, OSC will be a big one. But just for me, it opened up a big like realm of possibility to start thinking about, this doesn't need to be the computer that's like visible at the installation. I can have multiple smaller computers doing things. In my mind, I think of it like an octopus, where an octopus has like a central brain, and then all of its tentacles also have like their own like localized nervous systems. So you can have little computers doing very specific things and all like networked back to a main computer. So that's a big thing in interactive installations, I would say. So that's kind of an overview of like different ways to get information into the computer. Now I want to talk about sort of specific ways, specific hardware. And so to me, this breaks down into sight, you need some kind of camera. Sound, you need some kind of microphone. And then if you want any kind of like tactile things or like physical sensors, that's going to be some kind of Arduino, some kind of microcontroller. And then everything else is also some kind of Arduino, some kind of microcontroller. So you either have a camera, a microphone, or a microcontroller. So different types of cameras. I think computer vision is gonna be the most used way to get information in. I think it's the most accessible, the most understandable for the user. And there's probably more I could say about our culture having a very high like emphasis on sight in general. But different types of cameras. So obviously regular camera, webcam, any kind of just regular color image, that's what you're used to. And previously, this would not give us much information, but we're gonna hopefully be able to use MediaPipe later. And this is an example of modern AI being able to extract way more information from just a color image than we could 5 years ago, 10 years ago. And so this thing earlier, where he's tracking his hand positions. This is one of the he helped create the MediaPipe plugin for Touch Designer. So this is computer vision, and he's just using a webcam. That's kind of like the power. That's like why MediaPipe was invented. Is it does things that before you would have needed like a Kinect or something to do. And with AI, we could just use a webcam or any kind of camera. Depth camera. So this is called a Kinect Azure. This, if you remember the original Kinect like used for Xbox, it was basically could track your skeleton for like gaming stuff. Kinect Azure, same family. I believe it's more targeted for like robotics. So robotics and interactive installations, essentially the same field. They get research budgets and so better equipment than us. But yeah, Kinect Azure. I would have brought it today, but you need all the Kinect stuff is made by Microsoft, so it doesn't work on Mac. But the important thing about this is that it uses infrared to detect depth, essentially. So essentially, it's two cameras. It has a color camera that it like maps against its IR camera. And so basically what I'm trying to say is one type of data you can get with the camera is like, what's the color of what I'm looking at? Another type, if you add an extra sensor, is like, what's the depth of everything relative to the camera? Similar to depth is distance. So this obviously doesn't look like a camera. This is what's called LiDAR. And I mentioned it on the very first day that Waymo's self-driving cars, they have a weird thing on top. That's a LiDAR. and they also have cameras, whereas Teslas just have cameras. So a LiDAR basically just shoots out a laser, and this thing on top here spins 360. And so whenever the laser is broken, that means something is there. And so this is a way to detect distance. And I picked this image to specifically show like you could get this one for less than 100 and use it yourself. And so there are better and worse ones. This one does have like a touch designer implementation. That's a little bit finicky because it's not an official implementation. It's like someone made it. It's on GitHub. It takes a bit of setup, but plenty of people use it in their installations. And the last type of camera is heat. So this is also infrared. Maybe bad memories from COVID times. We didn't want to touch anyone, but we needed to figure out what their temperature was. So we had an infrared camera do it. And so you could use this in your installations for the temperature or simply just for the color mapping. And you could combine all four of these to get as much data as you want out of a camera. So hardware for microphones. I could have gone into like audio, the different types of mics, but they basically all do the same thing. Unlike cameras where different types of like light give you different types of information, there's only one kind of audio. And so the different mics are just, do you want to be more sensitive or less sensitive? Do you want it to be like directional far away or 360 right in front of you? So any mic will do essentially. Now Arduinos. This is where it kind of gets interesting, and unfortunately outside of the scope of this class to actually dive into Arduino. But this is where interactions can get very interesting. And I guess before I show this, I'll show you a time that I used it. This installation here, I called Distorted Memories. And so on the screen is a sort of constructed family video that my friend made of her like home pictures. And I'll go into this so you can see. This is Rachel. Oh yeah, if she were here, she might be able to explain it. But right here is actually, this is a Raspberry Pi. For our purposes, same thing. Just a tiny computer. And next to it is the sensor. Let me see if this will go away. Right there is the sensor. And this particular one is called an ultrasonic sensor. And so it uses ultrasonic sound to detect distance, essentially, basically sonar. And extremely cheap. Like, it sounds complicated. It was like probably $3. How did I use it in this installation? You could see it here. I just said the closer you get to the screen, the more distorted it is. So that's a slider. And again, going beyond the technology of it, the concept is that we are always reconstructing our memories, and the further away you get from it in time, the more it feels like a solid thing that you can clearly remember. And then when you actually go to try to remember it, all of the details are distorted. And so, very simple interaction, very simple concept, but very hard to portray this concept without the use of technology. So this is where, like, the whole point of this is like the medium can inform the message a lot. So I wanted to show you a little bit about microcontrollers. This is called Arduino. Arduino is just the name of the brand, very popular brand, but you can get microcontrollers from multiple brands. I guess show of hands, does anyone who knows what Arduino is? Yeah. Okay, I'll explain a little bit deeper as I was planning them. So in Arduino, I'm trying to think of the best way to explain. These are like different types of Arduinos. So I think the best way to explain it, again, is just, it's a tiny computer. Now, this is what's called a microcontroller, which means there are a ton of things that it can't do. Like it's probably not going to play video or anything like that. So generally, what people use them for are these things right here. These are called GPIO, standing for general purpose input and output. And so basically, a microcontroller is just a way to connect sensors, is one way to think about it. And how I would use it in Touch Designer, there are many other ways to use it, is most likely I would just find whatever sensors I want, and then I'd have to write code on the Arduino to most likely send OSC to my computer. But you'll see Arduinos in all kinds of like DIY maker projects. Like I think one of the most popular ones is like automatically watering your plants, right? You could have a sensor that detects the moisture level of your soil, and when that gets too low, press this button that turns the water on. That type of thing. So it's really made for this I/O thing. And the different types of Arduinos are like the same thing as different types of computers. Some have more CPU than others. Some have smaller footprint than others. Some have more like inputs and outputs than others. But they're all basically this purpose. And if you ever break apart like a random like home appliance, you'll see something like this inside. Like if you have a digital alarm clock, on the inside of it is going to be something that looks like a motherboard. It's a little tiny computer connected to some buttons and sliders. And so this is how all of our electronics work, at least the digital ones. So that's the microcontroller, and then you attach sensors to it. So I wanted to show you this website of like when I was trying to figure out what are all the types of like inputs you can have. And I said it was kind of spiraling out of control because outside of sight, sound, you basically would go to a website like this and just try to figure out what modules are available. So I was like, oh yeah, we could just look through some of these. These are their categories: weight, cameras, location, barometric. I'm about to click one at random. Does anyone want to see anything in particular?
That TVOC air quality one is the sensor I was mentioning earlier. That category you have up there.
Oh, air quality?
Yeah, TVOC.
Yeah, so this one does temperature, humidity, air pressure, and gas. This is called Adafruit. And Adafruit, again, is like a brand that makes these, but there's other brands and other sensors. They're useful as especially as like a way to categorize everything. But yeah, air. So this is like all air quality and gas sensors, different types of gases. Let's see. This is a big one, accelerometers. Think about your phone. Your phone knows what orientation it's in. It has one of these in it. That's exactly how it does it. So these are like gyroscope, it knows orientation. Accelerometer, it knows like when it's moving. I'm trying to think of anything else. But yeah, this is what you would use if you had like a handheld controller and you wanted to be able to do like this. You'd have like a little gyroscope in there. Oh look, a Wii nunchuck, because that's exactly what a Wii nunchuck does. It has one of those in it. These are like card readers. Same idea. You could make a specific barcode. I actually had I didn't have like a full installation idea, but I thought like NFC chips and things like that, and this like a mag stripe. You could like make cards for people where they had to go around the installation and like swipe to unlock things or something like that, or reverse. They could have the reader, and they have to go like find these tags and cards and stuff. Let me see. Oh, radiation, like a Geiger counter. Let's see. Humidity, motion might be interesting. Oh yeah, I'm actually planning to do something with wind speed. That would be cool. Yeah, you could be on this site all day looking for sensors. I think so I guess something I should mention is that there's probably a million ways to break down all these categories. And I don't even think they're necessarily consistent about it. Like, for example, light, color, and photo is a different category from camera. Rightly so, but the reason why I said that was that you can use light to detect different things. Let me see if I could find a specific example of what I'm trying to say. Like, this is a light sensor that detects proximity, and then this is a light sensor that detects UV light. So this is sort of categorizing it by like method, but then there's different things that you could be sensing in this category. And maybe I'm over complicating it, but the thing that I'm trying to say is like the information that you want, there might be multiple ways to get it, multiple types of sensors. And one might be easier to use than the other, or cooler to use than the other, or more relevant to your specific idea than the other. So yeah, when it comes to like anything outside of cameras and microphones, you really just end up looking for what sensors exist and try to figure out what you can do with them. And then you just remember that at the end of the chain, it's just going to output a number that you hook up to a button or a slider. And this is sort of the test of my framework, is to realize that one of the most complicated things we've ever made, an Earth orbiting satellite, is just a fancy Arduino. Like, there is a computer inside of it. It needs to figure out its orientation. There's a little gyrometer inside of it. It needs to send information back to Earth. It has an antenna that sends out radio waves. It receives radio waves. So it literally is just a little computer with a bunch of sensors and motors to adjust its own position and things like that. It's an interactive installation. And it works exactly the same way. At the bottom of the chain, there's either going to be buttons or sliders connected to whatever it needs to be connected to. So the last point I want to make is probably the most important, but also the hardest to get across. When it comes to new media art, the sky is the limit, or the limit is your imagination. And that is both a blessing and a curse. You can literally make anything, and especially when you start going beyond screens. And so I wanted to show a couple examples of this. So Olafur Eliasson is sort of a new media artist of a previous generation, where he's not necessarily working with computers so much. He's really interested in like optics and light and perception. And so this is an installation he did that, let me see some more pictures. It's like a constructed circle that you walk into. And when you walk on this plate here, that's like a pressure plate that sends, lets this thing know in the middle and sort of turns on like a thing that vibrates the water. So by default, you would be getting this like circle, and then as people walk into it, it creates this vibration thing. And the point I wanted to make about this is that all of the technical pieces of this are, in some sense, irrelevant. And if you were focused on like the technology of it, you would miss all the other cool things that you can do in the world. Like the core of this installation is reflecting light off of water. And then he just said, how do I make the water vibrate? It's really that simple. And so when this will come up much more when we talk about outputs, where the sky becomes the limit. But if the output's not a screen, then now you have all of the real world to start trying to manipulate. And you could put a motor underneath a pool of water to make it vibrate. You could attach a bunch of mirrors and make them move like this. And I wish I could come up with more random examples, but it could literally be anything. That's why it's so hard to come up with examples. So that's one of them. Let me skip over to this one first. Raphael Lozano Himmer. He is a new media artist, kind of our generation, but still a little older. He's like extremely established. So he has like 20 years of like tech-centered installations. And I probably could have picked any of them, but let's watch a short thing about this one. And there's no sound, but if it doesn't explain it, I'll explain. Or I guess I could just go ahead and explain. There's like a conveyor belt, and in this block, there's like must be a camera, and I think the projector would have to be like above this. But the point is, as the object goes through, it gets scanned by whatever like camera is underneath here, and then it's permanently part of the collection that gets projected onto this paper now. And honestly, I couldn't tell you what it's about. I mean, it reminds me of the airport for sure. Or maybe about like, are digital things ever forgotten? Like you dropped your physical thing here once and now it's in the installation forever because it's just an image. And when you think about it, it really wouldn't be that hard to even do, at least the like basic part of it. There's probably a bunch of headache about the actual conveyor belt part of it and making sure that like lines up. But he's literally just taking a picture and then projecting that picture, right? And that might be a good way to like emphasize this. Is I'm kind of saying that the tech of it is just taking a picture and then projecting that picture, and that says nothing about the actual installation, right? Like it goes so far beyond the hardware when you're making an installation. And let me do this last one that does have
You know
some.
that feeling of being on the subway and you look around and everybody's on their phone? And it's eerie. Seeing people in virtual reality headsets is a representation of this moment in technology. I read the white paper for a startup that wanted to put computer implants in people's brains. We're at an incredible inflection point where technology begins to meet the body. So I wanted to do a piece about this kind of constant mediation that we're experiencing through our devices. The anatomical theater in Berlin from the 18th century, where there were live dissections and anatomy classes, seemed like an appropriate place to talk about where technology is in the body. When you walked in the anatomical theater, you saw people in those bleachers looking through VR headsets at their hands. In the VR headset, the whole story is blossoming from the palms of your hands. And it's this love story between a nervous system and my avatar. They were in this dialogue of both creating each other and destroying each other, kind of like what happens in love and then this kind of relationship that technology has with us. When I produced that project, there were no human subjects that had brain-to-machine implants, and now there are 9.
I'll probably put this in an email too. Rachel Rosen is a very interesting artist working in new media. She, like me, is very concerned about digitizing human beings and what that means. So yeah, she has a lot of cool work about that. So yeah, to sort of reiterate a couple of the key points is that if you want to get information into your installation from the viewer or from the environment, your only options are using some kind of camera, some kind of microphone, or one of the million types of sensors that you can attach to an Arduino. And at the bottom of the chain, it's either going to be a button or a slider. That's really all there is to it. And everything about like what to make, that's the art of it. It's like it goes so much further than just what technology am I using. The technology, and in fact, it can be a mental trap to try and make the most complex thing when, you might just need to step on a thing that vibrates another thing, or you might just need to take a picture and project it. So yeah, that's the end of our interactivity lecture. We'll take a break and then get into touch design.